All right, we are back. Hired Labs Coding Bootcamp. We are in week 6 of 6. This is the end, the last day. We have built our app, and actually, I need to go back real quick for a few things that we were stuck on last time that I just wanted to mention. So, remember, Alex, when we were stuck and you hit the delete button or the confirm delete when we did the class-based views in the form, Shadiqua caught this actually. I wasn't putting the method post here. I can show you. Let's go over there and do that. So this is making up from last time. So when we go on my site, templates, whoop, oh, I'm sorry, to do templates. So we need to do templates to do, and with the confirm delete task. And the reason that when we hit the button to confirm and nothing happened, I had forgotten this little thing right here, the method equals post. And so that literally just wasn't sending anything back to our server. So when we hit that button to confirm that we wanted to delete it, it wasn't doing anything because I forgot this little part right there. And it's in the documentation, but I still overlooked it. So ironically, Alex, you're asking me like, hey, do I memorize all this stuff? Clearly not, because I completely forgot that, even though it was written in the document right in front of me. So if we add that piece in there, it should function just fine the way that it was. And then I think I actually left the recording. Shadiqua, you remember I had that error that it was mystifying myself. I forgot to
Mhm.
put this as view at the end. That was the mistake I was
Um,
making. And once I put this back on there, it all worked great. So um, little lack of attention to detail on my part, but that for method equals post critical, or else nothing will get sent back as a post method. And then this little as view is critical to make your class based views work. All right. So back to our last day. Now that the app has been built, and we're going to do advanced topics and next steps today. So we're talking about version control systems and collaborative coding today. So the collaborative coding, again, the piece that we were talking about just shortly, if you weren't able to set up your SSH and your GitHub accounts and stuff like that before today, completely fine. We'll talk about how that works and the pieces you could do with it, and you can go and do that after, and it's be like homework for today. But we're going to talk a lot about version control systems specifically. Um, Git is the version control system we're going to talk about. We're not going to get super in depth into it because there's a ton to it that could be like an entire course of its own. Very, very basics we're going to use. But before we dive into that, let's just review quickly what we've done up to now since the last day, what we did in this course. And if you remember the first day, this is what we promised that we would do. So we promised we'd do the same thing as a coding bootcamp, which, to be fair, we probably can't really assess unless you go take another coding bootcamp and compare it to this one. But the tangible objective, we made a fully functioning web app from scratch. That we did. I know Alex Shadiqua, you definitely got that done. Aurelius Young, were either of you was able to catch up with this as well and complete all the steps?
Oh yeah.
Nice, nice. Okay. And then our last intangible objectives were demystifying coding for folks who had never seen this before, maybe thought it was something they wanted to do, um, and give, quote unquote, you the tools to build anything. I know that we definitely gave you those tools, pointed you in the direction that we've started you off on the right foot to go and dig in further and however you want to take this, whichever direction you want to go. Even if that's, like Shadiqua said, never touching it again, that's totally fine because hopefully we did do the part before of demystifying it for you to where it doesn't seem like it's some sort of sorcery that coders are doing. It's something that is accessible, is possible to do. But again, I don't want to assume that we did that for you. So we're going to send out some feedback forms after this to everybody that signed up and everybody, even if they didn't come to class, they're just watching on the videos. If they signed up and they've been receiving the documentation up to now over email, we're going to send a feedback form and really, really, really appreciate your feedback on that. I personally like negative feedback because that helps us improve. And you're not going to hurt my feelings because I was not issued feelings in the Marine Corps, so I have none. But this is generally what we covered as a breakdown. Again, syllabus. We talked in the first week about the basics of programming. We talked about how computers understand what we write into it, the real high level syntax of Python, so we could start using it a little bit. Then in week 2, we talked about algorithms and data structures, what those are, what it means, different ways you could put data together. Then weeks 3 through 6, really, we built our application since we wrapped up last time with our CRUD operations. And then today, what we're going to be doing is our advanced topics and next steps, which is going to be our version control and how we collaborate with other people. So let's dive into that, version control systems and collaborative coding. So I've got a few more slides today that we're going to go through, not a ton, before we get hands-on with it. And I do want to start playing around with our version control system. So first of all, before we talk about version control systems, let's talk quickly about versions. So this should be fairly familiar because we do talk about these things all the time, but I want to make sure that we're clear on what these things mean. So versions, again, of software, it's just files and directories. So we're talking about different versions of those files. There's something called semantic versioning, which I'm sure we've all seen. We talk about like version 1.0 and 2.0 and stuff like that. Those numbers have meaning. That's what semantic versioning means. Is, nerds like myself like to talk about language in terms of semantics being how humans ascribe meaning to things. And so that just is saying that these numbers have a specific meaning. So the first number is usually three numbers. It can be two. There are all kinds of different variations of this. What I'm showing here with a three number system is pretty common. It's kind of a standard way to do it. The first number is the major version, then a dot, and then a minor version, and then what's called a patch version. The difference between those is the major version is usually like new features, and there's just like a whole bunch of updates and really new stuff, and they're generally not backward compatible with older versions. So for example, Python 3 is the major version that's being used now. I think the newest version out is 3.12 point something. I'm not sure what the patch is, but Python version 3 will not work with anything written in Python version 2. So when I first started coding, Python 2 was kind of just getting done and 3 was just coming out. And there were a lot of, like I learned 2 and then had to learn 3 and had to make sure that the projects I was working on were either of those 2 or 3, because if you had something in 2, you couldn't write the way you would in 3, it would not work. So the backwards compatibility is the major thing with a major version of something. The minor versions typically have new features to them. There's typically some fairly substantive changes in the application and software that's being built, but they tend to be backward compatible, usually. That's not a hard and fast thing. So for example, like I said, the latest version of Python is 3.12. I think the version that's in Python Anywhere that we're using is 3.10 point something. Again, I forget the patch version. There are differences between 3.12 and 3.10 where some things don't work exactly the same way. But for the most part, you can expect minor versions to be backwards compatible, meaning like a version 10.7.8 will work with 10.6.8 or 6.3 or whatever, generally. And then patch releases or patch versions are not usually for new features. It's mostly bug fixes and fixing small things that come out. So, as a major release comes out, say version 1.0.0, the patch number will usually go up a lot quicker than the other numbers because you'll start finding bugs and fixing them. And each fix that you put in will increase the version up by 1. Then there's also, sometimes we talk about versions. We talk about the versions in reference to the steps in the development process. So from the beginning step, there's development where you're testing things out, you're writing your code for the first time and experimenting with things. And then once you've finished to a certain point, you think it's working the way you want to, it may slide into the testing stage of the development process. And then that will move into a staging environment where you may put it up into something that's very close to the final environment. So like in terms of a web application, it'll be up on a website somewhere, but it won't be accessible to outside users or anything like that. It'll be for internal testing to make sure that it runs on the internet in principle through HTTP and things like that, and make sure that those server interactions do actually work before it goes to the last phase or the last version of your code, which would be in the production version, right? And that's the one that's live, that's out there, and people are using it. Whoever those people are, whoever those users are, that's like the end product. So this is another way of thinking about versions. Sometimes you'll hear people talk about which version of code you're working on in these terms. So then version control systems are tools to control and monitor those things and move them along the pipelines of either the release versions that you put out or those production staging development and all those different things that you're going through. And all of them are doing this. They're tracking changes made to files in directories, right? So we've talked about how software is files and directories. These version control systems, their sole purpose and all they really, I mean, they do a lot, but their fundamental purpose is to make sure that the changes in those files are tracked. There are tons of different kinds of them. That kind of start out, the old school ones were just local, what they call RCS. It's not really important that we know exactly what these are, but just kind of to highlight that there's a bunch of different ways of approaching this. This isn't as commonly used very much anymore because it's just on one device. There are centralized version control systems, which were kind of the next evolution of it. And the issue with these is that only like one person could work on something at a time, and they were very easy to conflict with other people. So if you tried to work in a group, it was very difficult. So it came along with distributed version control systems, and that's what we're going to talk about in general. Again, it's not important if you know these different control systems. Just know that now the popular way to do it, the most common one you're going to run into, are called distributed version control systems, and they allow multiple users to work on the same code base and not conflict with each other. The most common one, and the one that we're going to use, is, well, I say it's the most common because I think anecdotally that's true. I never actually looked this up, but it's called Git, G-I-T, and it stands for Global Information Tracker. It's also kind of a play on words with get, like G-E-T, to go get something, because that is what you're doing. You go and get code and you give code to other people and things like that. We'll show how to do those things with it. But this is exceptionally common. Pretty much anybody that's going to go and try to apply to any technical job, they're going to want you to know how to use Git. It's a massively used version control system, and we're going to use it today. It's built into Python Anywhere, and we'll talk about how it is used and what it is used for. So very commonly used. It is a distributed version control system that allows people across different groups, different teams, to interact with code in a way that's not going to step on each other's toes. It's ways that large companies can handle the projects that they do in ways that they couldn't if they were stuck with just centralized version control systems where conflict is a lot easier. All right, so that's great. These things exist, but like, why would we do this, right? So again, I'm going to put this on like every slide. It just tracks changes made to files and directories, right? So every time we make a change, these version control systems are going to keep track of that for us. And what that means is that it'll allow us to develop experimental features without affecting the main code base. And then you can also save these things up in some sort of cloud provider. So when we talk about GitHub, it's got Git in the title. We'll talk about a little bit more why they do that. But it's something separate of Git as a technology. Git is a standalone technology that you don't have to do in a cloud. You can do it just on a device and just locally. And it's going to help you keep track of the versions of your software. So it ensures that the proper version of code is being used at all times, right? So in like the staging or the development, whichever the latest or whichever one you're supposed to be using in the environment you're in, these version control systems make that a lot easier to do and know that you're in the right place using the right code. I mentioned before, it allows you to collaborate with other developers. Is one of the main things that people use it for. That's why large companies use these things. Things like, I mean, any technology you could think of, Google or something, couldn't possibly operate at the size it could if only one person could write the code at a time and do things like that. This version control systems allow huge groups to work on really complex projects and keep track of which files, when they've got thousands of directories and thousands of files in those directories, keeping track of the changes that are made. That's what these systems make possible. But it is good for managing projects of all sizes, right? So I use it for my own personal little small things, the same way, well, not the same way because not the same scale, but the same way like YouTube uses it for their things. You know, we follow a lot of the same processes. When I'm writing something for myself, I will use Git as a version control system to make sure that I can develop, make changes, and roll back to certain points in time, right? So one of the things that we're talking about when we talk about version control systems, we've talked about our application in terms of a physical space, and the analogy of, if you remember, we were talking about a physical plot of land and a building physically being built in that plot of land. What version control systems do is they add the element of time to that. So where you could take a snapshot of where the building was at a certain time and then keep building on it. And if something doesn't work the way you wanted to, you can roll back to another time when that building looked different, right? And that's not something we could really do in physical space. We could do that with software using version control systems. So it's a very good tool for projects of all sizes, small to large. And it's also a way to set up some really arguably kind of sexy stuff, but this continuous integration and continuous development, or CI/CD pipelines, are something that's typically just in large projects. You're not probably going to do this on your own things. This is something where you have large teams of developers developing really complex projects, and there's a lot of changes happening all the time. these version control systems allow that to happen to where people can make changes and they send them up to places and then some testing happens and it rolls through this entire cycle of people are always developing changes and then integrating it into the code base. And it's just a continuous cycle of updating, improving, making patch fixes, releasing new features, all those things. And version control systems allow this work to be done. If we didn't have version control systems, I can't even imagine how we would do it, honestly. So this is sort of the why of version control systems. And we'll be kind of stepping through this quickly. Any questions up to now on any of this? All right. So let's talk a little bit specifically about Git, the global information tracker. It, just like the others, tracks changes made to files and directories. That's its main purpose. That's its main function. That's really what it's about. That's what it does. That's why it's valuable at all sizes of all levels of projects. It does that by creating what's called repositories. And these repositories are really, they're just directories themselves, but they contain, in a manner of speaking, the files and directories that you want to keep track of. So as we're gonna go through this when we get hands on, it'll become a lot more clear. But the repository doesn't exactly contain these files, it just tracks them, right? So anything in your file system that you want Git to keep track of, it can. Unless you explicitly tell it not to, it will keep track of pretty much everything from the directory that it's in and all the subdirectories, all the files that are inside of it, except the ones that you tell it to ignore. And I'll show you how to do that as well. And this also gives you the opportunity to store things in a cloud provider. But there are tons of cloud providers. I mentioned this already, GitHub, which is one I'm sure some of you have heard of for sure. I know, Alex, we were talking about this before. There are plenty of others, though. There are tons of these cloud providers. There's GitLab, there's Bitbucket, OneDev, Cogs, and it just goes on and on. There's a huge list of these things. You notice these top two, GitHub, GitLab, they have Git in their title. That's somewhat confusing because they are not Git. They're a cloud, they're a website. GitHub is a company. You can go work there. They are separate from Git as a technology. So if you know, like we mentioned, if you didn't get a chance to do the pre-work for today and sign up for GitHub, that's totally fine because Git as a technology is built into Python anywhere. You don't have to have any of these cloud technologies at all to use Git. They're two separate things. I want to make sure that's really clearly separated in your mind too, that Git is a thing and GitHub is one of the many cloud places like, you know, it's like Google Drive and what is that? OneDrive or whatever other cloud storage things. These are very similar, except they're tailored to version control systems like Git. Does that make sense to everybody? All right. Yep. So that's it for slides. I said I have a few, and that's a few. So let's get out of this and go talk about Git a little bit more. Before we get totally hands-on, I want to show something that's in our free coding resources. I got to zoom stuff in my way. If we slide down to over on the left-hand side, we got this version control section. And underneath that, we have just Git as a version control, even though there are other version control systems. This is seriously by far the most commonly used one. So the official Git website is here. You can find out more information there. It's great docs. If you want to set it up on your own device, you can. Again, there's no need for any of that now. There's a link to GitHub if you want to set up there and sign in and get that set up. Totally can. There's also this cheat sheet, which is hugely, hugely helpful. This is by far my favorite cheat sheet for this. I use it to this day all the time. It says, get the simple guide. It's exactly what this is. Because this, as I said, we're talking about time in a layer of our sort of universe of the thing that we're making. And this is also going to give us almost the ability to create, sadly, what I think of as a multiverse. And it can get very, very complicated. So having something like this that'll boil down just the steps that we need and gives a good visualization of the process and the commands used is exceptionally helpful. So we use this as I was, you know, instead of writing our own documentation on each step we're going to do, I was going to give you this instead because it's something you can go back to, look at. Again, I go back to that to this day just to make sure that I'm doing the right things, remembering the right commands and whatnot. Just got a thing in here on how to set it up on each of the major flavors of operating systems. And once again, if you're doing this outside of Python anywhere, if you want to do this on your own device, this is where you would go to set that up. We don't need to do any of that now. We'll get into this creating a repository and what exactly that means here in a minute and how we check things out. I'm going to skip down real quick to this example that they have of the workflow. It's a really good, simple diagram of the workflow that we're going to follow that is a very common pattern for how you use Git. So you have your working directory. And for us, that's our My Site top level project directory, right? So where you're doing your work, it's where you're doing your coding and doing all the things you're doing. And what you're going to do with Git is you give it a command to add all of the files and folders and everything that is in your entire structure. And if you look at this middle thing above where it says index, we use that for our homepage, but index meaning it's the staging environment. It says in parentheses here. This is just one place that things are pointed to. Pointers are concepts you'll hear a lot. And if you look at this, it looks a lot like the tree diagram that we had, because this is representing a file structure, and what's meant to represent that it's going to save everything that's in your working directory unless you tell it to skip something, right? So by default, Git is going to track everything that's in your top level all the way down to the bottom, every file, every folder that's in there as it is. So you're going to add everything into the staging area, as is called, and then you get to look at the files that are changed, make sure that you want to keep those things, and then what's called commit, you commit them into your repository, and it will be at the head pointer. And this is like one spot that is saved. So this head is like a moment in time that has been snapshot. It's a snapshot in a moment in time. And the head is pointed at like where you are now, basically. It's like this is the now, this is the most recent, this is the where we are. And as you make more of these, what they call commits, you will have a history, a log of all the snapshots you've taken. So you can go back to an older snapshot once you've made a change. If you don't like that change, you can roll it back to another place. So this is generally the workflow that you're going to be following. You're going to make changes in your working directory. You're going to add those changes to some sort of staging area where the index will be pointed at them, and you can look at those things and make sure that you want to save them permanently into your record of changes by committing them into the record.
And
So
Jeff, is this related to a specific project that you're working on, or is this just in general where you would hold different, I don't know, pieces of work that you do? Like, what is this related to? Like how, because I need to conceptualize it.
Yeah, absolutely. So this is to make it really confusing. No, let's think about this in terms of our project, right? So let's think about working directory as being my site. So it's like the project root directory is usually where you put your Git repository, right? So the working directory in our case would be the top level my site project folder. And then all the things that are specific to just that project are going to be stored in this index and commit area. Does that answer your question?
Okay. So you could essentially have one of these or this type of setup for any project that you work on.
Yes, exactly.
Okay.
You're going to end up doing tons of different repositories. And what's cool about this is once you get the hang of this, since you know how to run Python code by running, the Python 3 and then the name of the root thing, like we've done manage.py, we've done main.py, right? You can take other people's, and I'm going to show you how to do it. You could take other people's code from GitHub. Even if you don't have a GitHub account, you could just go to Git. I mean, you may have to log in, but you can find code places. And if it's in a Git repository, you can copy their code to your machine, copy their repository into your machine, and run their code from your machine. And it'll be in a Git repository. And that's the beauty of these things. So yeah, you'll have several of these bound to like a specific project. Cool.
Thank you.
Yeah, sure. Relis, you had a question?
Yeah. Can you run the code in index before committing to the head?
Yeah. Yeah, absolutely. Absolutely. So we're going to, I'll show you exactly how that goes and what we do, because this is all done. Basically, we're going to work today pretty much exclusively in the Bash console. And this is all done in the exact same place. So you run the code, make sure it's working, and then once you know you're good with it, then you commit it and save it, and you're just still, working the way you normally work.
I have a quick question that I probably should have asked at the very beginning of the class, not this class, but like first session.
Sure.
So when I told my friend that I was taking this, she asked me what we would be working with, and I said, oh, primarily Python.
Sure.
But we have, I guess, used more than one language. Is that what I'm saying? Am I saying that right?
Yeah, kind of. Yeah.
So the languages, I guess, can be used together. Like, but she was saying that, oh, well, it would be great if you were learning R.
Yeah.
So
I mean, if you wanted to be a data scientist, R would be awesome.
Oh, okay. Because I'm like, because I don't know the difference.
Sure.
But she knows about all the things. And So I'm wondering like how the way Python and Django and all the ones does R work with these two like that, or how does that work?
Yeah. For like as far as Git goes.
No,
Or
no, I told you this is completely unrelated. I should
oh
have
yeah,
asked
yeah.
this
So
at the
yeah,
beginning
totally.
of
So
the.
R is if you think back to and I could flip back to that first day, R is on that spectrum of languages. That would be a specialty language, kind of like SQL is. So it's for a
Ah,
it's
okay,
not a general programming language like Python. It's like for a specific purpose. So like I said, it's for um any kind of statistical analysis work is usually what R is for. So you're not
got
going to
it.
use it to write programs really, but it's for a very, very specific purpose.
Okay, but we have used SQL to some degree with this, right?
To some degree, yeah. Like we used Python within Django to boil
Uh-huh.
down to SQL,
Okay,
but we didn't actually write any SQL directly ourselves. But we did
okay.
have to mention it to understand what it is and that we are interacting with it to interact with a relational database. But we didn't write
Uh-huh.
any SQL statements or do any SQL coding of any kind.
Oh, okay, cool. I mean, I just wanted to, I
Yeah.
should have been asked that, but I thought about it as I was asking about the working directory.
There's
So
no there's
thank you.
never a bad time to ask a question. It's always a good time to ask a question. Don't even worry about it.
Thank you.
Sure. Sure. All right. So this we're going to go through this a couple of times today, and this becomes very, very, very habitual. Where you do like you add things, you check them out, make sure that you want to commit them, and then you commit them. This is a really, really standard workflow. And we're going to do it like 3 or 4 times today to become a habit. These are the steps we're going to go through. Again, we don't need. I will demonstrate these. So you don't need to memorize these right now, but this is literally the process. You just say git add, and then either the file name specifically. This has an asterisk here. I use a period. I've honestly never used an asterisk. We might try it out. And then you have to give it some sort of message to get this message. The reason for this is that it puts it into a log, and if you don't put a message in there, it's got nothing to put in the log. So it requires this from you. But we'll get into this. We'll get into this soon. Pushing changes, we don't need to worry about that right away because that's pushing things up into a cloud repository, and this whole remote thing is when you're working with remote things. So we're going to skip down here to branching because branching is also very important to understand because this is the beauty of it. This is how you make your multiverse. This is where you do like a split in time. So we look down this kind of chart here at the bottom, and we go along this bottom line is what they call the master branch. And I'm gonna call this out now. This is sort of outdated terminology. It probably is still going to be the default when we start a new Git repository. The main branch will be called master. About 9, 10-ish years ago, everyone decided like, hey, that's from slavery. We don't want to call things master. So now the convention is to call things main on your main branch. And I'll show you how to rename it, just so you know how to rename it. And it is the convention now. Everybody expects your main branch to be called main, not master, but you'll still see it in documentation a lot. Master is the kind of the default way that Git used to call the main branch back in the day. But that's what this is showing here in the bottom. Is this master branch here at the bottom is your main source code. So if you look over here on the left, you think about this. Again, I try to stay out of linguistics too much, but probably because we're English speakers and we read left to right, we think of motion and time as moving from our left to our right. So on this chart, you imagine the left side over here as the beginning and time is moving to the right. So as we go along, we get to this point and we're like, oh, you know what? We want to make a new feature. So if you think about it in terms of our project, our My Site, we have the basics of it, but we're like, say, you know what? I want to add a way for users to log in and have their own profile in my application so they can have their own to-do lists. And it's not just one to-do list that everybody accesses, right? So instead of just starting to write that into your main code and possibly break the code you have and run into points, because you saw several times where we got stuck. Just like I admitted before, I fat fingered things and overlook stuff all the time, even though I've got documentation right in front of me. So to avoid those problems and breaking your main code, you create what's called a branch where you slide this off into it's the same code at this point right here. And you can start at this point on your new feature X branch is the name of this branch. Start making your changes and develop your changes and do what you need to do. Right. So you can start adding user profiles. You can start adding, new APIs that do all kinds of crazy stuff. And it will stand separate and exist at the same time as your master branch. And you can go back and forth between these two, and it's now different code, even though they have the same starting point. And then once you're done with this feature X and you think it's good and it works the way you want it to, you do what's called merging it back into your master branch. And then at this point on, they will be the same in the sense that this master branch will have all the things that you developed on your feature X branch. They won't be connected with each other. The feature X branch will still be distinct from the master branch. If you continue to make changes here and do other things on this side past this little circle where it was merged, it won't reflect back in your feature X branch. But all the changes you made after them, after you merge them, all the changes you made on feature X will now be a part of your master at this point. And so the time aspect of this is like once you merge it and you're rolling, you're like, yeah, cool, that feature X is great. And then you realize that it broke something over here closer to this right arrow, and you're like, oh, we don't like that. You can roll back to here to some other point before you merged it and get back to what you had in your master branch before this merge happened. And it'll be this code in here in this area. It still exists, and you can still step back into that. Everybody tracking this conceptually? Is making sense? You got a question, Realize? What's up?
Yeah, would it be ever a chance to branch on the branch before merging back to the main line? Like say you got feature X, and if
Yep.
you need to make another change without really affecting feature X, could you branch off of feature X, or do you have to branch off another point in the main line?
Yeah, man, I love it. There's no like hard restrictions on that. You can branch from wherever you want, kind of as many times as you like, right? So a lot of times what'll happen is exactly that scenario where say you're doing, like I said, some sort of complex-ish new feature where you want to do a new function to your website, and it's going to take you like, I don't know, 2 week cycle or something like that. You got all planned out, and you start working, and you're right about here developing your branch on feature X, and then something else comes up as a bug that breaks here. And so you'll branch off another branch off your master branch, do like a hot fix and push it back in. And you could have other branches coming off a master. You could come in here and be like, oh, you know what? I got to this point on my feature X and I want to try something else out. Like it all works great, but I want to try something else. You could do another branch off of there. And that's really where the complexity comes in, is because you can make really complex branches or trees with lots of branches. So yeah, that's 100% possible. This is a really simple boiled down way of looking at it. And honestly, this is the kind of thing that when you're working by yourself on a small project, this is sort of what your branching and merging will look like. So you'll branch like you'll do one thing, you'll break it off, you'll do your work and you'll pull it back in. But when there's several people, big teams, it'll be several branches going all kinds of places.
Mm.
So yeah, that's absolutely possible. Any other questions about this concept here? Because this is really fundamental to what we're doing. Alex, what's up?
Yeah, so the whole point of doing this branch stuff is try to because they're not trying to affect the main code. Is that
Yep.
why?
Yep. Exactly. So you can go when you break off. So like imagine that our to-do list is out live and people are using it like I don't know, an app that's out there doing to-do lists, right? And you have users in there using it, and you're like, man, I want to make something new for it. You can break off this branch and start developing whatever new feature you want to here, and people are still using the code on this branch. They're not even touching their new feature branch until you merge it together. So it's exactly what it's for. Is you can get it to a non-functional state on your feature X and completely break everything, and it won't affect your master branch if you don't merge it.
Okay.
Yeah, it really is.
So initially you're cloning the main line, and
Mhm.
then that child of the main line, you can make any changes you want, and then once the changes are made, you can then fuse it back together or merge it back together to the main line.
Yes,
Okay.
exactly. And I don't be a stickler about it, but I'm really careful. Don't use the word clone because that's a term in Git that we're going to use shortly.
Yeah.
Branch. You're making a
Okay.
branch. But yes, that's exactly what's happening. It like at this point right here, when you branch it off, it's exactly the same on both. And then as soon as you start making changes to feature X, it'll start being different
Okay.
without affecting the master branch. Cool. Good questions. Any other questions? And again, this will be a lot clearer when we start playing around with it. And we're gonna go through these commands specifically. Again, this is a reference, a really good reference. Come back if you forget what we covered today. We're gonna do all these things. The checkout is how you make a branch and how you move between branches, and then you can delete a branch with this D flag and stuff like that. And then again, we got push in here, but don't worry about that. Um, and here's the command to merge, but we'll go through these commands here in a minute. There's a lot more to this. As you see, I could keep scrolling down, even though this is the simple, you know, thing. This has got tons of info in here. We're not going to get to the full depth of this. So let's go get hands-on with it. And a lot of these branching concepts are going to become a lot clearer once we get our hands onto it. So let's go back to Python Anywhere and let's go to our console. go back to my console since I had to first show where I had broken everything. All right, so I'm just in Bash console. I'm in my home directory, and we're gonna start since we're gonna be doing things in our my site project just to get used to how this is how we would do it normally in a real project. We're gonna use that same project stuff, but we're not gonna do anything to the actual code in that project except demonstrate stuff lightly. It's gonna be all Git stuff. But so just
And
for
Jeff,
yeah,
before we start, I'm stuck on that passphrase thing. So how can I just exit out of this so that I can start where you are?
oh, and the thing that you're in, trying to set up the
In the
SSH.
Bash console, yeah, I'm
Yeah.
stuck on the pass. It won't let me type anything.
Okay. Yeah. So if you're ever stuck in a Bash console, hit Control C and see if
Oh,
that
I
just
can,
like
okay, I didn't know. I could
takes
use
you out
that
of there.
right there.
Yeah. So Control C is called keyboard interrupt, and that'll stop any process in a console, and it should give you control back.
Yes, thank you.
Cool. And then just as a side note, if that doesn't work, do not hesitate to go back to your like list of consoles and just close the console out and start another one. That's also a totally viable option. But Control C is a good command. All right, so let's, like we have before, I'm just out of good habit. I'm going to start our virtual environment. Well, this time I'm not going to force y'all to answer my questions. And I'm going to move into my top level directory. And this is where we are going to get started, right? So this is our top level project root, my site directory. So we know all the things that we have inside of it. And I've mentioned that Git is built in already to Python. It's already loaded. We don't have to load it. But to verify that and verify anything that you have, you could do the name of the thing that you think you have or you hope you have, and then space dash dash version. Sometimes just dash V, but I usually do the full dash dash version because it's more reliable to work. And if you have it installed, it'll tell you which version you have, right? So there's a version 2, major version is 2, minor version 25, and they've done one patch fix in that 25th minor version. All right, so we have Git. Great. What does that mean? First thing that we normally do is we can use this command called status to see where our Git status is right now, like where we stand, where our files are, what branch we're on, all that kind of stuff. But since we haven't done anything with it yet, but we have Git, that won't give us anything yet. So if we do Git status, it's going to say, oh, this is not a Git repository or a parent. I don't know what you want me to do. So the first thing we got to do before we get going is we have to create a repository. And the way we do that is a command called git init, which is short for initialize. When we hit enter on this, it's just going to say initialized empty Git repository, and then it tells you where it was initialized. And once again, we want to keep in mind that this is in our top level project root. And we can see that it is, I'm just going to use my ls, not the tree command. I'm just do ls and then ls or dash lha because I like it in a list. And then the A is going to show hidden files because it's a .git, it's a hidden directory. And as you can see right here, we have our .git directory alongside of our manage.py and our database file and all that kind of stuff. And if we really wanted to look into it, we could look into our .git directory and just see that it is seriously just files in here. It's files, these other subdirectories. There's really no need most of the time to go into this directory and do much with it. But you can just see that this is, no matter what the technology is, it's files and directories. So if you start, say, using other people's Git repositories, or you make a mistake in a Git repository in some way, just get rid of this directory and it'll disappear, right? So you just remove it the way you would remove anything else. Like if I did rm rf.git and then I do git status, it'll say, oh, there's no Git repository, right? So we need to do git init, and now we have our repository back. So again, it's just files and directories. All right, cool. So we've initialized our repository. We have an empty repository. Now now that we have our repository, let's do the status check again and see how it's different. Oh, I'm zoomed in a little much. Let me zoom out so we get this all on one screen. Okay, so when I hit get status this time, it gives me a little bit more information. So first it says on branch master. So this is kind of an older version. We'll have to change that name. And I'll show you how to change the name. It says no commits yet. So we haven't committed anything. And then it says untracked files, right? And this gives us a whole list. This is everything in our project so far. And it's all red. It means we're not tracking any of this stuff yet. So it hasn't been added into that index. If you remember the no simple stuff, we are just here. So we haven't added anything yet. Yeah, really. So what's the question?
think I missed a step. Mine says fatal, not a gift, get repository or any parent.
Yep. So you got to do this get init step. So
Yeah.
so get space init, and then you should have initialized empty get repository, and then you should be able to do get status. You good?
Yep.
All right, cool. All right, so we have untracked files here. So this is, everything is not tracked. If we go back to our guide, it's like, okay, we got to add everything. We could start adding, but before we do that, I mentioned before that this will track everything unless we tell it not to track something. So I emailed out this earlier. I can drop this into the chat if no one has it in front of them, but we're going to use this get ignore file. That's a really standard kind of boilerplate thing. I can show you where you can grab one from GitHub, and there are places you can find them online. This is one from an actual project we're using. So some of the stuff down at the bottom, like some of these, I think, are project specific, but everything above that is just boilerplate stuff, right? And so if we look at this, before I move on, actually, we have things in here like DB SQLite 3, and because we don't want to upload our database itself into version control, we'll have things in here like our PyCache. Remember, we ignored that in our tree statement because that's this huge file. We don't need to save that in our version control. There'll also be things in here like our VM, our virtual envs will be in here. Our .env files will be in here. We want to ignore those, right? Here's our .env, .env.dev, our virtual envs, all these stuff. This all comes standard environment stuff because this usually has sensitive information in your .env file. That's the whole purpose of it. Like the secret key, you might have like passwords to your database and credentials to APIs and all that kind of stuff. You don't want to save those to version control because version control, if you push it up into a cloud provider, that's public and people can get to it, right? So you want to ignore these things, and that's what get ignore as a file is going to do for us. So I'm just going to select all this. I'm going to copy it, go back to our bash console, and we're going to make a get ignore file here in this same directory. So we're in our same my site directory, not inside the get directory. It's going to be at the same level that we're at. And I'm going to use V to make this, I'm going to clear this up. I'm going to use V. I'm going to type in .get ignore, all one word, right? So it starts with a dot and this get ignore, no file extensions, nothing else. I'm going to open this up. I'm going to hit I so that I enter insert mode. Then I'm just going to paste in all that stuff that I copied out of the example get ignore file.
Wait, you typed in v.get ignore?
Mm-hmm. Yeah.
And when I put that, it said command dot, you didn't do enter, you just,
Spaced, VI space dot get ignore.
oh, I did vi dot space.
Yeah,
Okay.
VI space, then
Dot
.get ignore. The
space.
name of the file is .get ignore.
Okay, and then just copy and paste everything that's on the get ignored list.
Yep, everything is from this example file I sent out, and then just paste it all in here. After you hit I to enter the insert mode, right? And then I'm going to hit escape to get out of insert mode. And then I'm going to hit colon, WQ to save all these changes and close out this file.
And am I copy and pasting starting at 1?
You could, yeah. On that, in that file, yeah, at 1. I don't think it really matters. If you skip a line, I don't think it's going to be the end of the world because it's just going to look at all the things that are in there and it'll just ignore each name that it finds. So if it finds it, it'll skip empty lines. So that's not crucial if you skip a line, but yeah, just start at the top.
Okay. And then I'm sorry, you did what now after that? Copy and paste.
Yep. You hit escape to get out of the insert mode.
Okay.
And then you hit colon. You should see a little colon down here in the lower left-hand corner.
Uh-huh.
And then WQ, lowercase. That'll be right. W stands for right. Q stands for quit. And that should close you out and take you right back to your console.
All right. Thank you.
Yes. All right. Got a couple of questions. Aurelius, I think your hand is up first. What's up?
Yeah, that's what I'm stuck at. When I copy and paste it into get ignored and press escape out of insert mode, it's not letting me type down in that squares. Keep giving a bell. Like every
Yeah,
time
you shouldn't have to. So you hit escape, and then you just start. You just type colon.
yeah, it's not letting me type colon.
Suddenly you type anything.
Nothing, yeah.
Oh man. All right. Well, you could try. I don't know if a keyboard interrupt. If you do Control C, if it'll get you out of there.
Control C.
Yeah. See if that works. That might make it worse. Hopefully not. All right. Worst case scenario is you just got to wave off and go to the GUI and make this in the Python Anywhere GUI. Just make sure you put it in your my site directory.
It says type colon QA.
Mm-hmm. Yeah. So just try typing that without clicking anywhere. Just do shift colon and then Q or WQ.
Yeah, it put me back in insert mode again.
Okay. So hit escape again.
Yeah, say the bell, then put me back in.
I got a bell too, but it still let me type.
Yeah, it gives me a bell and then it lets me type. Like it doesn't. There's no overt thing. Like the insert just disappears. So like if I enter insert mode, it says insert at the bottom. When I hit escape, it just it doesn't give me anything. It just says okay, there it is.
Yeah, I'm not even getting that. I'm pressing it over and over and just getting the bell over and over.
Oh man. All right. So if you get totally stuck here, there is no shame in just closing out this bash console, destroying it, opening a new one, and creating this in the GUI is totally fine.
How do I do that?
So if you go back up here and just go to your consoles, you can just hit the little blue X right here alongside your console and it'll kill that console and then just start another one. And then if you want to just go into files and go to your my site directory and then just type in git ignore up here in this bar and that'll make it in your GUI. You just do git ignore and
I
hit new
see
file.
ignore .swp right there, but type in
Yeah,
something.
so that's a temporary one because you started saving it. But if you don't have this file by itself, then I mean you could throw out this swap thing right here. That's okay. That's like an unsaved version.
So just dot get ignore a new file.
Mm-hmm.
All
Yep,
right.
and then it should take you to the blank editor and you copy and paste from the example into there.
And this should show up where should this show up?
It should equal. If you
Which
did this
file?
in the console, you shouldn't have to do this part. This is only if you couldn't do it in
Oh,
the
okay.
console. This is the alternative to doing it in the console. Alex, what's your question, man?
Yeah, so this process, you're only doing the first time, or you're gonna do every project?
Really good question. So you're going to need to git ignore in every project because you're going to want to ignore things in every project. That's why this thing is so standard boilerplate kind of stuff.
Okay. So people just like every time they do a create new project file, it's pretty much a copy and paste.
Pretty much. Yeah. And when we get into GitHub, I'll show you that it comes standard in there, like depending. So, if you're going to be writing in Python, it'll give you all these options based on what language you're writing in. And if you're doing a Python thing, it'll say, hey, here's your git ignore for Python. And it'll give you this basically what I have here as the example minus whatever I told you was our kind of our own project based stuff.
Okay.
Is it okay if it copy and pastes the numbers as well?
The
Or
numbers, like the numbers
100?
beforehand.
Yeah.
Yeah, no, you don't want those.
Okay.
No, you want to be like this without numbers in front of it. So copy it from the dock, not from your console. All right. Okay, so once we have our git ignore in there, if we do git status again, we're still on our master branch. We still haven't done any commits, but we see we have our .git ignore listed on our untracked files. All right, so now we're going to go through and do our first commit. We're going to add this file to it. The reason being we're going to add just this one file. We could add everything at once, but because we want to be very sure that this ignores everything after this commit that we want it to ignore and it doesn't commit anything that we don't want it to keep, we're going to run just the git ignore by itself. And typically, again, when we start a project, this is what we would do first. We would set up our Git repository, put in our git ignore, and then maybe add a README, a license, and that's it at most. Those three documents, your git ignore, license, and a README doc as your initial commit. That's usually what you start with. You don't usually start doing this with all this project stuff in here. But it's okay to do it this way. It's fine. It's just we don't want to commit everything at first. We want to make sure that our git ignore functions. So we're going to put it in as our first commit. So once you got your git ignore file, we're going to git add, and then the name of the file. And this is helpful because it says untracked files, use git add, and then file name. It tells you exactly what you're supposed to do to add things. So if you forget, you don't even have to reference anything. It pops up every time with git when you do git status. But I'm going to do git add and git ignore. When I hit enter, it's not going to tell me anything that it did, but I'll clear this up so we got more space. And I'll do git status again just to look at the difference. All right, now it still says no commits. We're still on our master branch, but now we have new file, a git ignore, written in green, up in changes to be committed. And then we still have our untracked, the rest of our directories and files down here. And this git ignore, again, now we commit this. We're going to make our first commit. So now we've added this, we've staged it. So we've gone, if we go back to our diagram, our all of our project directory and stuff is still here. And we've only added that one git ignore into this staging section. So we got one file right here. Now we need to commit it in here to save it, make our first commit. So to do that, we do git commit, then space dash M. So git space commit space dash M, and that means message. I think that's what M stands for. And then we're going to open quotation marks and give it some sort of descriptive thing to put into the log. It doesn't really matter what you put in here. The standard for your first one is just to put in initial, if I could spell initial, commit, close it off, close parentheses, or parentheses, quotation marks. Then when I hit enter, it'll give me a little bit of information. It'll say master root commit, and it'll give this little number right here. This is important because each commit you make will have one of these numbers, and that's how you roll back to things in the past and stuff like that, how you reference commits. So that's the serial number for it. And then it'll give the little comment right here that you gave it. It'll say what it did. It inserted 149 lines in one file, and it created this file altogether. Yes, Alex.
Oh, go ahead.
Yeah, so I did type git commit dash n initial commit, and then it says like, please tell me who you are.
Same here.
What?
Interesting. That might be.
It says git config global user email. You example git commit. Yeah, I got the same thing that Alex got. And then it says fatal empty ident name for.
Yeah, okay. So it should give you on screen exactly what you need to do to set those parameters that it's looking for.
Oh, is this because I didn't do that thing earlier?
Yeah, it's because it's not connected to anything on GitHub, so it doesn't know who you are as a user. And so you can set a global user, and it should have the exact commands to run there for you to do that.
Git config global user and then email. So you put your email and then git config global username, your name. So that is the commands.
Yep. Those are the things that you need to put in there. So it should give you the commands to fix that error.
Okay.
Which email do I put here?
Well, so I would say use the one that you signed up on GitHub on, but if you haven't signed up on GitHub, then use what email that you will use to sign up on GitHub.
But I actually did sign up on GitHub. That's why.
Then use that one.
Okay. And is it the entire thing, like git config, all of that, or is it just the
Yep. Git config and then whatever the global user, I forget the name of it, but it should, everything it says in that, there's like 2 lines that tells you to do and enter the name and the.
And you do these independently, not at the same time, right?
Yeah, do one at a time. All right, Aurelius, you got a question?
I think I'm just gonna have to catch up with the video because I'm stuck in the GUI because I destroyed my bash, or I got rid of the bash command, and so moving on in those subs, I didn't know where to do it in this.
Okay, yeah. So once you've made your git ignore file, then just go open a new bash console and go back into it and come back into my site directory.
So I got to do all the steps that we had to get to there before.
I mean, you got to, move into your my site directory, and then you shouldn't have to initialize another repository because you have it. You should just then be able to add, do git status, So it'll just be these two steps, just get status and see what you have, and then add your git ignore and do your initial commit.
Okay, now I got it.
All right. Okay. Cool. Okay. So now that we've done our initial commit, I'm going to show this as an example. So git log is a really useful thing to show you your history of what you've done, the history of your commits. And this is why it says, I don't know who you are, because as you see, it wants to put the author of the commit into it. It can't just be like an anonymous, we don't know who you are. You committed this thing. We don't know what that is. But it also gives you a whole lot of information right here. So here's that full ID of the commit that we made. And then it also says there's that head and the pointer and the master. These could be in different places at different times, but right now they're in the same place. So it's just telling you that information. And it's got the little note that we added. It's got the time that's in there. So there we are. We have our initial commit. We've saved one set of things, but we're still called, as you can see, still called the master branch. So let's rename that real fast. I'm going to show you how to do that. It's very simple. And we use the command branch, git branch. Now I'm going to do that by itself first before we rename anything and show you what this does. If you just do git dash or space branch, it'll list all the branches you have, right? So if you go, remember our branching thing, and Aurelius, you had the question if we could have multiple branches. We absolutely can. This will give you a list of them, and the one that you're on will have this little asterisk next to it, and it'll be in green in here. It'll list any other ones you have. We only have the one. But we're also going to use branch to rename it. So we do git branch and then -m. And then we do the name of the branch we want to rename. So right now it's master, space, the name we want to give it. So git space branch, space -m, space master, the name of the branch we want to change, space main, the name we want to change it to. When we hit enter, it will give us no information. So I'm just going to do git branch again. And we can see that we still only have one branch, but it's been renamed to main and also changed in our parentheses here. I forgot to call this out. Our virtual environment over here on the left in parentheses is in white, and we're still in a virtual environment. And our git branch is right here in yellow parentheses.
And is the virtual environment in that box on the left the repository? I mean,
No,
is
the
it
virtual environment is the one we've been using that's got all of our Python packages.
No,
and
no,
all that
no.
stuff
I'm
in it.
saying in that diagram that you're showing about the moving from the one place, it's not in that.
This
Yeah, it's
right
not
here?
in the working direct. Is it in the working directory?
Yes, but we're ignoring it.
Okay.
Actually, it's not in the working directory. In our case, no, it doesn't have to be. And we're ignoring it from Git anyway. So it's not going to be in anything involved here because we don't want to send our virtual environments into version control.
Okay.
Alex, what's up?
Yeah. So what does a -m do again?
That's for renaming a branch.
Renaming. Okay.
Yep. So when you do git branch and then you give the M flag, it's going to rename that branch. And so you give it which branch you want to rename and then the name you want to give it.
That's the only purpose for -m.
With branch, yeah, that flag for branch specifically. The -m might do other things, like when we do our commits, it's for the message that you add in there. For branch, the flag. I mean, it could be used in any number of places. For branch, it renames things. For commit, it adds the message that you want to add.
Okay.
All right, so now that we renamed our branch, let's go ahead and add everything else, right? So if we do git status again, it should be, okay, so we've got all these untracked files and the rest of our stuff in there. We want to add this now to our thing. And we can tell that our git ignore is working because we don't see our SQL 3. We don't see our database in here because we left that out in the git ignore. So it's not even staged in the untracked files, or not even listed in the untracked files, not staged rather. So now this time I'm going to do git add again, because I'm going to use period. Instead of listing each file and directory itself, I'm just going to do git space add space period. And that's going to mean everything. So it's going to take everything that isn't being ignored, and it's going to add it. This might take a second. But when it does, I'm going to go ahead and skip doing the status again because it's going to show us what we do when we commit this. So I'm going to just go ahead and do straight to the commit without showing the status again. So I'm going to do git commit -M to enter the flag or the line that we want to keep in our history. And then it doesn't really matter at this point. We put anything like, say, something descriptive like added project directories. And it's going to give this whole list of create. It's going to show everything that's in here. If we scroll up to the top again, just to make sure we know that we had our .env in our internal my site, right? In the same place as our settings.py, and we don't see it listed here. So our git ignore is working right. We don't have our database. We don't have our .env. So it's good. So we're solid on this. So now we've committed everything. And if we do git status, it should say on branch main, nothing to commit, working tree clean. So this is generally like when you start, and once you get going, once you've got your Git repository set up and you're ready to start your day and you're working on a project over and over again, this is generally where you begin, right? You're on some branch and it's clean and it's good to go. So let's go through some real quick examples of how branching and merging work and what that does. So we're going to make a branch and we're going to make a change to a file, and then we'll merge that change into main. Very, very simple. We'll go through these steps real quick. So the first thing we do is make a branch. And to do that, we do git and we use checkout as one word. So git space checkout space. And then we're going to pass. Good.
I'm sorry, just clear my throat. Let me.
Oh, sure. No, you're good. You're good. You're good. Don't worry about it. All right. So git, so it's checkout space, and then we give it a B flag. So -B, and that's telling it that we're going to make a new branch, right? And then we can give it whatever name we want to. So we could call it, it doesn't even matter. We could call it feature X for all we care, just like in the example on the thing. And we do is says switch to new branch feature X. And now we're here. So this is just like on this example down in branching. We're right here. We just did the branch. So we're at this point where the main and the feature X are exactly the same code. There's no differences. There's nothing. We haven't done anything to it yet. So we could even do that, check our git status to confirm that, say, hey, we're on this branch, but there's nothing to commit. Everything's the same. So when it says working tree clean, that means there are no changes as of yet, right? So what I'm going to do is I'm just going to make a simple change, right? I'm going to do this in V. It's up to you if you want to go into your files and do this in GUI, but I'm just going to open up our base.html template and just add something to it, and then come back in here. This is an arbitrary change just to demonstrate how this works. But I'm just going to open up using V, new templates /base.html. And I'm going to enter insert mode by hitting I. And then it doesn't really matter, somewhere under this end block to make sure that we're not really breaking anything. I'm just going to add a paragraph tag that says, I'm new. I don't know what to do. It's a quote from my favorite movie, Joe Dirt. Okay, so there we go. So we got the new paragraph in here. And it's the most essential coding. We've just solved all of the world's problems with this. So I'm going to save it.
How did you do that? Hold up.
But so
I did insert. Oh, wait. And then how were you able to type there though?
Just pick a spot and start typing.
That didn't seem to work for me.
Are you in insert mode?
Yep. Okay, let me see. We're 20.
It doesn't have to be exactly what I did or where I did it. It really just any change at this point is totally fine. This is just to demonstrate that we can make a change, and then it'll only exist on this branch. So you don't have to write exactly what I'm writing. It doesn't have to be a p tag. Doesn't have to be in this spot. But you can make a change to any file that you want.
Okay.
So I'm going to save this change that I made by hitting escape to get out of insert mode and :WQ to come back here. And now if I do git status, it's going to say, oh, there's a change. All right. So I'm going to say, all right. So I'm going to do git add. And I'm just going to do all, even though I only made one change, because that's typically what I do when I'm working on these things anyway. I just, any changes I make, I just hit all. It's a lot faster that way. If I change 4 or 5 files, I have to list them all explicitly. And then I'm going to say git commit, give it a message like updated base.html. And it'll say, all right, great. So we did this one file change, one insertion, because we inserted one line. So it counts the number of rows, lines that are added to that file, not keystrokes or anything like that. And now, if we check out and go back to our main branch using checkout again, except this time we don't give the B flag, so we're not making a new branch. We're just going to move from one branch to another. So I'm going to do get space checkout space name of branch I want to go to. So in our case, main. So get checkout main. It says switch to branch main. We can see in our parentheses here, we are in the main. We were at feature X. And now if I just open up that same base.html, we'll see that on row 20, I added mine on row 20. There is not that paragraph tag. It does not exist here because we have not put it on our main yet. Right? So I'm not going to do anything to this. I'm just going to go ahead and quit out of here. I was just showing you that it's not there. So what we can do is if we want to merge that change, it's still over on the feature X. If I went back to feature X, I could show it there. Do you guys want to look at that, or you just trust me that it's there?
Can I look at it?
Yeah, let's look at it. All right. So to move back, we do get checkout, and then the name of the branch we want to do, feature X, and then we'll go back into our templates base HTML, which I just use the up arrow to get back to this command without having to write it all over again. When I hit enter, you see on the row 20, there it is. So all I did was move from main branch to this branch, and there's that change that I made and saved before. So it's still there. I don't have to do anything to it. All right, so now what I want to do is merge this into our main branch. So let's back in our example. Let's say we've done a whole bunch of changes, and that writing that paragraph was the ultimate change we wanted to do. So now we're at this point, we need to merge it back in together. So there's one branch with all of our updated code. So to do that, we need to be on the branch to which we want to merge. So in our case, we need to go back to our main branch and be there. So we do get checkout, the branch we want to go to. Now we're on our main branch. And then we're going to do get merge, and then the name of the branch that we want to merge into the branch we are on. So in our case, we're going to do feature X is the one we want to merge into main. So we're on main, and we're merging feature X into main. When I hit enter, it's going to say updating. It's going to give this other thing, and it's going to say fast forward, which means, again, there's a lot of time related things in here. But basically, it's just saying, hey, we made one change in here. One file was changed with one insertion. And now I'm still in my main branch. And if I just open up my base.html, that line that I added on row 20 is there. So that, in a nutshell, is basic branching and merging. Alex, what's the question?
Yeah, so when you actually do this for your project, before you merge it, you want to make sure that this new code runs without the error, right? You want to test it
Absolutely.
first, right?
Yep, 100%. 100%. We shortcut all that just to show these mechanics. But yeah, when you're actually developing stuff, you'll spend a lot more time over on your whatever feature X branch. You'll do a bunch of stuff. You'll test it out. And before you merge it into main, you definitely want to make sure it works. So you can commit code that doesn't work. Like if you're on feature X or something like that, and you're trying to figure out how something works, you get to the end of the day and you're really tired. And you're like, man, I'm stuck. You can commit and save your work with the app not working at all. It can be in a broken state and you can still commit it, and that's okay. But yeah, you'll definitely want to test it, make sure everything works before you merge it into main. Any other questions? Yeah, really. So what's up?
So you can test it before merging back into the main line?
You can, and you should. There's no like built-in test or anything like that. It's not going to stop you. So like if you write broken code in feature X and then merge it into main, you're going to break your main code too. So it's on you. It's like absolutely incumbent on you to do those that diligence of testing your code, making sure it's not breaking before you merge it in. And if you go and work with other folks, which we're gonna transition to that here in the last few minutes and show how you would do collaboratively through GitHub and things like that, they should have some sort of safeguards on how they pull stuff in. And I'm gonna show you how that works. And I'm really gonna encourage you all to take this and try it out and pull down some of our code and submit what's called a pull request, which is asking us to pull, or whoever runs the code base, to pull your changes into their main branch. But they should have their main branch protected to a way that you can't just break it. That answers your question. But yes, you should be testing things before you merge them, like in your own projects. Any other questions on basic Git operations, branching and merging before we slide into the collaborative end of it? No? All right. Cool. So for this portion, we are going to move out of this. So I'm going to just go ahead and go back to my home directory. I'm going to get out of my virtual environment, and we're going to try grabbing some code off of GitHub and show the process of how you pull down somebody else's code, run it in your own environment, and then send up a change, make a change and send it back to them to look at and do something with and incorporate into the main code that they have. And so this is something, again, I really encourage you all to do. This is something if you haven't set up your SSH connection or you didn't get that to work before now, this step you're not gonna be able to follow along, and that's okay. I do encourage you to do it later. And this is something I really encourage you to use us as a practice and pull down the same repository, make some changes to it, mess around with it, and go through the practice of doing pull requests with us, because you know us, and it should be like a low barrier in entry. But this is GitHub. So I'm over on GitHub, and this is our organizational page on GitHub. You can find us at Higher Labs Inc. So that's the name of our GitHub thing. And we have this bootcamp poker game. This is a purely Python written repository. So this is generally how it's laid out on all GitHub pages. There are a number of repositories on here. This is our main application. You can go ahead and read that if you like. It's mostly Python. But I'm going to open this up and show you what's in here. So when you're on GitHub, this is going to actually have all of the code itself. So you can come in here, and here's our main.py. And you can just go in here and look at it and just have a look at the actual code. So this is kind of a beast in all one page, but it's all Python. So you can come in here, read this. It's not real complex. It's just a game of poker based on Texas Hold'em. It's got all kinds of bugs in it, though. There's plenty of opportunities for folks to hop in here, make some changes, and improve this thing. But the idea here is that you can come on to GitHub. I can make changes right here directly and just edit this here if I wanted to. This is a fully built out way for people to collaborate and work together on code, right? So we can see what branches we have over here on the left. We got this main branch. We can make some other ones. We got some tags. There's all kinds of stuff we can do in here. We have our git ignore. Again, we could look at that. Fairly standard. We have a license. We could talk about licenses maybe sometime. Not super important. We have our README, which is just a markdown thing. And what I'm going to do is show you how to grab this code and run it ourselves. So the first thing we're going to do, if this is your project and it's your GitHub thing and you're working on it, or if it's an organization you work at or you're in and you have access to, you'll generally just go to this code thing and you'll just copy this code. But for right now, what I'm going to do, and you actually all might be able to do this if you have your GitHub account should equal, you might be able to give us a shot with another non-SSH way. You might be able to try the HTTPS way. That's another option in here. So if you'd like, you can give it a shot. I'll show you where that would be. But, you know, that's up to you. So the first thing we're going to do, though, is we're going to fork this, is what it's called. So this thing up here on the top, we got this edit pins, watch, and this little button says fork. And what that's going to do is going to create a copy of this repository from this organization to my personal GitHub account, is what it should do when I hit fork. And the reason for this is it's going to create a complete copy of the repository that I will then be able to pull down, make changes to, and I'll be able to send back to the organization and say, hey, I made these changes. Can you pull it into your thing? Right. So if you're out on GitHub or anywhere else and you find a repository you want to pull down and just use and just play with, and you don't intend to send any changes back to the organization that you got it from, you don't have to fork it. You could just clone it, which we'll show in a second. But this step is pretty much required for any organization you don't have internal access to. But there are plenty of open source projects out there that you can contribute to that this is the way you would do it, right? You fork it first, and then we're going to go through the cloning steps, right? So you're not typically going to fork your own repositories. This is when you're forking somebody else's repository. All right, so it's going to go in here. It's going to give us a chance, like I can name this something else. I'm going to just leave the default name because that's cool, because it's available. So skip down here to create fork. And when I do that, it's going to make something that looks very similar to what we were just looking at, right? So this has basically the same kind of stuff. except now it says this branch is up to date with the original main branch. We have sync fork and contribute, right? So we don't have anything to contribute. It says no new commits. Enjoy your day. Everything is up to date, right? So let's pull this down, run the code, make a change, send it back up, right? So again, if you're not trying to make a change, this portion of cloning somebody's repository is how you would take their code and run it. And I actually, real quick, I mentioned open source before. I want to make really clear that open source doesn't mean it's free, but it means that the source code is accessible and you can read it, right? So there's plenty of open source projects out there that are like fully, there's this company called Supabase that does hosting kind of like Python Anywhere, but for different technologies. They're a for-profit company and they're fully open source. And the CEO of that wrote a really good argument about why open source is the way to go. But all that means is that the source code is available for you to read and get a hold of, possibly run on your own device. All right, so we're going to go to this green code button. When I click on this, it's going to give me this drop down. Do local. There's a code spaces option. That's something that's built into GitHub. You can mess around with that some other time. It defaults to this SSH, but there are other ways to do it. So there's a GitHub CLI, which you're not going to mess with. That's something you have to download it itself. There is an HTTPS option. So this is what I was talking about before, Shadiqua. If you have a GitHub account and you're able to fork the repository and get it up to this point, you could try running this. You may run into problems because this is being pushed to the wayside. It's not as secure as SSH. So they're trying to not use it as often. But give it a shot. If you haven't set up your SSH, but you can get to this point, try the HTTPS instead. But I'm going to do the SSH because I have that. Either way, you select which one you're going to use up here, and we're going to copy it. We're going to copy this clipboard. And it's just going to copy what's in here, right? So again, I forked the repository that I wanted. So I made a copy of my own. And then I'm going to go to this code button, and I'm going to copy this thing right here. Yeah, Alex, what's up?
Yeah, when you do the fork thingy, do you
Mhm.
have to get permission from the owner who made this code?
You do not.
Um,
That's the beauty of it. If it's a public repository, and like this one is, it's a public repository, and the one on our site was as well. Anything that's public, you can go to GitHub and you can just fork it. You can clone it without forking it. If it's publicly available, feel free to grab it.
and if I fork it, like, does does he get notice?
Yeah, it'll count how many forks have been
Uh,
done in this. So yeah, they'll know, but that's generally a good thing, honestly. This is like kind of one of those things that if people are forking your repositories, that means they're messing with your code, and that's probably good. So I don't think anybody's going to mind you do that. And again, if they do mind, they can set their repositories to private. So you can have private repositories on GitHub that nobody can access, but any public repository you should be able to access by either forking or cloning.
okay.
Cool. So we're going to go through cloning right now. So the first thing we did was made a fork because again, we're planning on going and pushing the code back up. We're going to make a change and try to push it back up and do a what's called a pull request. So the next step is to clone this. And again, we can skip forking. If all you want to do is run somebody's code and you just want to clone it, you can go straight to the code button, copy it, and do these steps that we're about to do right now to clone it. Oh, I go back to my bash console. That's right. So this is my home directory. I've gotten out of the virtual environment by typing the word deactivate, just one word, deactivate, because we don't need to be in our virtual environment anymore. We don't need a virtual environment for this right now. Although it's usually best practice to have one. We're going to skip all that for demonstrative purposes. And we're just going to do git clone. So git space clone. And then I'm just going to paste whatever I copied from GitHub. So in my case, the SSH should equal, you might try the HTTPS and see how that goes. Either way, the command at the beginning is the same. You write git clone and then this situation here. When I hit enter, it should say cloning. It is going to ask me for my passphrase for this because I'm doing SSH. See if I can remember my password without saying it out loud. And I did. Okay, cool. So then once I've entered my password and it's connected the way it's supposed to be, it'll say remote, a whole bunch of information, resolving deltas and some other stuff. It'll give me back control. And then to make sure that I have it, I'm going to list what I've got in my home directory. You can see I have this bootcamp poker game directory in there now. So I'm going to move into that. And as I did that, you see that this little git thing popped up as main because this already is a Git repository. We don't have to do any of the initializing because we took this from GitHub. It already is a Git repository. Now, if I do LS/LH, you see what's in here. It's going to be the same stuff. We got the main, we got the README, we got the license. Well, I guess I could do with the A flag and see if our git ignore is in there. And it is. We still have our git ignore, and here's our git repository. So it's all the same stuff that was up here on in our repository on GitHub. It pulled down all these files into my local machine. And now I can run this game if I wanted to. So I do Python 3 main.py. It's going to take me in this little Texas Hold'em thing. And we're not going to go through like the full thing, but you enter your name and it'll ask what you want to do. Might actually zoom out a little bit because you can't see everything. And what this did is there's a whole bunch of, there's like 9 AI players. There's me right here. It gave us all starting points. I could say, oh, I want to play a hand by putting in number 1. It's going to deal out some cards. So I got Queen of Clubs and a 4 of Hearts. And then it's going to move around and deal out the cards. Everybody's going to put in their antes or their bets or their blinds. This is blinds because it's Texas Hold'em if you're familiar with the game. The betting action is going to move from player to player as the quote unquote AI players make their decisions. And then we can play some poker if we wanted to, right? So we can go around betting. The flop's going to come out here on the board, and we're going to do all that stuff, right? So this is what the code did. I pulled this down, and now I can use it. So now we have the code, and it's here, right? I'm not going to go through the full thing. I absolutely encourage you all to do this and run it on your own. Mess around with this game, make changes to it. But let's go through the mechanics of making a change. We've got a few minutes left. Let's see if we can knock this out. So I'm going to make a change to the README because that's easy to do. Totally simple. I'm just going to do V and then the README. And I'm going to come in here, do insert, and make some kind of change. Again, fairly arbitrary change. Let's say I don't want to redundantly say Texas Hold'em twice, so I'm just going to say that this is a coding boot camp poker game. There we go, right? Doesn't matter. Arbitrary change. I'm going to save that. I know I got git status. And it says, okay, cool. I modified the README. So now I'm going to say git add everything, even though I only made one change. And then git commit m fixed the main header. It's going to say which file I changed it in, so I don't have to tell the file. But again, the messages you put in here is going to be dictated by, if it's your own project, you can put whatever you like. If it's somebody else's project, you're going to probably follow what they want. But either way, it's got to have some kind of message in here to say what we did. It should be fairly descriptive. And now that we did that, cool. All right, so now I'm going to push this change up to my repository, right? So it's going to push it back up into my GitHub version, which you remember, I forked this from somebody else. Now I'm going to make it, I made a change, and I'm going to push this local change I made back up into GitHub. So we do git push, and we say origin, which is where we are, right? That's our origin is here. Or I'm sorry, origin is where it came from. So we're pushing up to the origin, and we say what branch we want to push. So our branch here is main. We didn't make another branch. We could have, probably should have as a best practice. You don't really want to usually work on main, but that's okay. So I'm going to say git push origin main. It's going to ask for my passphrase again. Try not to say it out loud so you don't know my secret code. Cool. And then once I did that, it's going to give me a bunch of information again. Ultimately, I'm looking for this at the end, though. It says, all right, cool. Here's another one of those ID number hash things that they got, and it'll say main push to main. Now, when I go back to GitHub, if I refresh GitHub, this is where it said that it was up to date. Now it says it's one commit ahead of this repository. So what I can do is I'm going to just contribute button. I now have an option to open a pull request. And again, I want to make sure that we're clear on what pull is referring to. It's from the standpoint of the owner of this project, right? So if you go to work on somebody else's project, you take their code, you clone it, you make a change. When you open a pull request, it's requesting that they pull it into their source code. So when I click on open pull request, it's going to say, all right, cool. It's going to do some automatic checks. It'll give you this little flag. It says, all right, cool. This is able to merge. There's no conflicts. I can add a description. You know, you don't have to, but you can. And then when you're done doing whatever you like to do, you can make markup, you add pictures, whatever you like, and you do this create pull request button right here. I'm gonna click on that. It's gonna take me into this area. Now, this is what I'm back at Higher Labs Inc. So I'm not on my personal one anymore, and I'm under the pull request tab. So this is from, since I am also the owner of this and I just merged it to my own, this is what the person is going to see on the other side, or the organization is going to see that you send the pull request to. They're going to see this page that says, hey, we got a pull request. I could go see all the pull requests that are in here, say fix the main header. So this is the message that I saved this commit as, right? That's why you want it to be descriptive. You want it to be something that everyone's going to understand what you're talking about. So you don't want to code this too deeply. But then they go into this, they can say, hey, like we can add comments, we can chat back and forth and say, like, why did you do this? And we could talk about it before it's merged. They can test it, they can pull it down locally and try it out, make sure that it fits, it does all the things they want to. And then once they're good with it, they can either merge it here or merge it in the command line. Doesn't really matter. But once we're good, they'll just say merge. And now that change has been added. The pull request has been closed. And that change has been made in the actual code. And as you can see, the README, which is the default here, changed from having the Texas Hold'em to say boot camp poker game, which is the change that I made locally. Yes, Alex, what's the question?
Yeah, is there any way that the owner of the code can look at which change you made, other than like reading the letter?
Other than reading
Or
the pull request?
yeah,
Yeah,
can
absolutely.
you see actual code?
Yes. You absolutely can. So let's see. I'm sorry. I just look at one of these closed ones. All right, so let's grab this again. Here. I think if we go over to commits, no, files changed. This will show you. All right, so this is going to show you a line by line change. So it says which file was changed to readme.md. And then it says that this file right here. So this is what it was originally. The red part was the part that was in there originally. And the green part is the change. So this is what they can look at to really review line by line the code. There's ways to do this in the command line interface as well. You can do git diff, and it'll show you all the differences in a similar format. It'll say which were added, which were removed, what exactly was changed. But this is part of this is part of what they can do to review this sort of thing and then make their decision if they want to merge code into their branch.
Okay, thank you.
Yep. Any other questions?
Yeah, I got one more question.
Yeah, shoot.
So after we create a GitHub account,
Mhm.
like, are we able to like go to a boot camp poker game?
Yep.
And do the same thing and test it out?
100%. And I would absolutely encourage you to do so. I would love it if all of you did that. And not just the
If you
bootcamp
make
poker
some
game.
change,
Yep.
yeah, I mean, if you make some change and do the pull request, are you gonna like accept it?
I don't know, man. You better not break my code. Yeah, no, I will. Absolutely. I'll look it over and we can go through the full code review. And I encourage you to do something, if you want to start out just dipping your toes in this to make sure you get the mechanics down and just change something simple in the README like I just did and add something to it, I will absolutely approve that change. But if you want to go in and check the actual code itself and fix some of the things, like if you actually run this game and try playing a hand, you'll see that it doesn't actually pick the real winner. Like we're not actually checking which hand was better than which hand, If you want to go in and actually make a change to the code itself, I would love that. And this is pure Python. So all the stuff that we did, this is classes, this is functions, all the stuff that we talked about in class, this is an opportunity to actually use it, mess around with it, and go through the mechanics of making a change. And not just that one, I would encourage as well with our main project, if you want to get that far into it, which is a little bit more complex, but it's also there to be done. And I encourage you to do that too.
So I don't understand what's the difference between do the all like fork and clone stuff,
Mhm.
other than like just go there and then just copy and paste to your own computer.
Copy and paste.
Yeah.
Well, so the cloning will take all the files and directories. And so you could open each one of these and copy and paste. You totally could, because you can get straight to the code, right? Like you're saying, like you just open this up and copy and
Yeah.
paste everything. Yeah. Well, so with
Just copy
this,
the code.
Yeah, you totally could with this one because it's one file. But check this out. So we go to our main. This is our main website with like our full machine learning and everything that's in there. That's a ton. That's a ton of stuff in here. You're gonna get. So here's a directory with all these different files, all these different subdirectories. Where's our main one? Here we go. It would just take you a long time. Yeah, you could do it,
Yeah,
but um,
it makes sense.
it's a lot faster to say clone, and it just copies all this stuff instead of opening each individual one of these templates and each individual one of these, you know, sub files and all these other things that we got in here. It would just take you forever to do it manually. So that's what it's for. Is you can get
Mm.
projects of basically any size with that one command of cloning.
Cloning is
What's that project that you're working on? HL main. What is that about?
So this is the code behind um, our website.
Oh, there's a website.
So yeah, like our actual website and the back end. I'm going to show real quick, kind of like what our this is like the back end of it that we use internally. And in here, there's how we tailor resumes. We have a thing in here that tailors resumes to job posts, uses natural language processing to do it. And there's an AI function built into it. You'd have to have like Google Cloud set up to run that piece of it. But um, this is like what we use kind of daily to run all of our operations. And I'm not going to open this up. I'd run a local version and show you, but I don't want to open this up and drop everybody's personal info and all the people that are participating in the program in here. But since we're recording, we're gonna put this up. But you could run a version of this. It won't have the live data that we have, but you could run this locally on your own machine and make your own way of tailoring resumes and stuff like that, and just take this and use it. Because again, it's open source, man. Like we encourage people to take it, run it, use it, try it out, make changes, send it back to us, contribute if you like. As kind of next steps for this, it would be good if you learn things like Docker. If you're not familiar with that, we don't cover in this course, but it's very, very useful. We use it, so it's something you can read and use on this. But yeah, that's what this one is. So you're more than welcome to clone this as well and run it locally for yourself.
So, I didn't get to do any of this because I got stuck in the Bash console.
Okay.
And I guess I had a question about, so the GitHub is the place where we, if you go back to the, well, you don't, if you go back to the diagram, so is is GitHub used to be the repository, or what is GitHub? Why do we need it? Do we need it?
Yeah. So GitHub, again, you don't need it. You could just do Git with no GitHub. This is a place to store your repositories in the cloud so other people can get to them, right? So we got 3 repositories here. This is the one that I used for the example, the poker game, that I really encourage everybody to play around with, no problem. This is where we store our actual, what we write as a web application that we run internally as a business. And this is also, if you just go generally out to GitHub, oh wait, this is just everything else. You can find other people's projects and run like other code entirely. So this is just, there's a friend of mine runs this open source project. It's not Python. It is written mostly in here. List what languages it's written in. So this is TypeScript, JavaScript. There's some CSS. There's some shell. But this is also an open source project. You could open this and run it and pull it down. And this is quite literally like what GitHub is about, is a place where people store their code either publicly or privately. And if it's public, you could pull down their code and interact with it, either run it locally yourself or send back changes. And that's what GitHub is about. So it uses Git, but it's more about the interacting with other developers. And so anybody that's looking to do this professionally, especially, as you can see on this one, again, this is, there's a buddy of mine runs this thing. As soon as you contribute to a project, it'll list you down here as contributors. All right, so there's 537 people have contributed to this. They're actual user avatars and stuff. So if you're building a portfolio of work, this is where you would do that.
Well, I guess that answered my question. I was going to ask, why would you contribute to somebody's thing that you don't know?
Yeah, absolutely. So it's mostly just to practice and do the work. Again, assuming you like doing this kind of thing or you're trying to do more of it. But that's why. So, but as you can see here, the used by versus contributors, there's like 144,000 users and there's only 537 contributors, right? So you can just grab stuff that you think is cool and use it and run it without contributing back, and that's totally fine. That's what people are good with that too. But if you want to actively contribute and develop a portfolio of work that's not just your own projects, this gives you a way to do that as well.
And you would want to access somebody else's code to help with the project that you're doing, or what's
Yeah.
the point in
You
that?
might.
Okay.
Yeah, depending on all kinds of things. Like I forget what this is something about the deployment end of whatnot. I'm not going to pretend I understand what this is doing, but
Mhm.
there are all kinds of reasons that you may want to get code from other places. And again, it could be full on programs. Like there are some things out there that are complete, I don't know, data analytics suites and stuff like that are fully open source code, and you can go get their code, pull it down, and run it. And that way you don't have to pay for a full, like they're paying for it, but if you know how to go and get and run code, stuff that people are paying for, you can come and get for free. So that's one reason you might want to do it. It might be something you want to use in your project. It might be something you want to just use as its own thing. Any number of reasons.
So like if you have the code, like this is so far-fetched, I'm pretty sure it's not available open source, but if Photoshop puts their code out there, I can get Photoshop for free if they have it on here.
Yeah, exactly. And that's the thing. There are seriously like full on, companies that are selling the exact same thing that they have here for free, just because most people aren't going to bother to run it at this level of depth, and they're just going to buy it as a fully built solution. But if it's open source or if it's available publicly, like this one is here, then you can grab it, run it, use it, however you like.
Interesting.
And it's all. So I mentioned licenses very, very briefly. Let's see if these guys have a license for sure. Let's see what license they're using. And if you're
Yeah,
not
that was
sure,
gonna be my next question, like,
yeah.
so people
So if
know,
you're not
like,
sure how you can use it, it'll say right here, you go to the license, and this kind of boils it down so you don't have to actually be a lawyer like I know some of us are. But if you're not, it'll kind of boil it down for you and say what you're allowed to do with it, right? So you can take this and, like, again, this is free, this is open source, but you can use it commercially. So like, again, if you three are like, hey man, let's go start a company, you could take my buddy's thing right here and go start your own company with this because of this MIT license. And this is a common license. Real common. MIT is one that you can use. It's out there. Um,
and this is like from the school MIT, or is this?
yeah, yeah,
Oh,
it is. And licensing is a whole world of things and why you would choose certain licenses. You got to be kind of careful with it because if you put the wrong license on it, trying to be all restrictive, you may technically lock yourself out of legally accessing your own code by your own license. So, open source licenses are a good place to start. Things like MIT license, real common. I use the GNU license a lot because it's just commonly used with Django projects, but MIT real common to use. And there's typically when it's open source, it'll come with this. There's limitations. Is there no liability or warranty? So it's given as is. There's no guarantee it's going to function or work or do anything at all, really. And that's kind of the assumption of it, that it's like, hey, we're not guaranteeing this is going to work for you, but you can distribute it, you can modify it, you can do it for commercial use, you can do it for private use, and that's all totally fine under this license. And it says specifically exactly, I mean, you see how long this license is, not very long, but it just says, again, right here, it's provided as is, no warranty of any kind, express or implied, but you're welcome to take this, modify it, sell it, do whatever you want to with it. It's pretty cool, right?
yeah, it's the Wild West, but
It is. It's one of those things that when me and my co-founder were starting Hired Labs, I'm kind of an anti-capitalist myself, and I'm all about open source stuff. And he's like, no, man, we got to lock this down. I'm like, dude, if the idea is that great, somebody else probably already got it. So relax. But, yeah, there's tons of really good open source stuff out there. So I really encourage you all to dig into this, look around, especially now that you know the basic mechanics, know how to run things, clone some stuff, try running it locally, find a project you like, try contributing, contribute to 1 hour for practice. But that is it. We're a little bit over time, but I'm glad you all asked these questions, and I hope we covered interesting stuff for you. You have some good next steps to follow up from here and go forward. Any questions before we wrap the entire course?
Yeah,
I
quick.
am just hoping. Oh, go ahead.
Sure, go ahead, Rose.
Say that you can run one of these codes. An example you saw was the boot camp poker game.
Mhm.
that wasn't no active site that we can go to look at. That was completely ran in code, right?
Yes, that was.
Is
That
there
was just,
is
this is the only place it really lives, is up here as purely Python code.
right? And that's going to be majority of the case of a lot of these codes. Like we can't have like a user facing experience with these codes.
You can. I mean, there's no reason that it doesn't have to. I mean, I would venture to say it's probably the majority of stuff you're going to find on GitHub is something you're going to run on like command line, like you have been. But
Mhm.
you know, like I mentioned, this project that we have, this open source here, this is the full on web page with the user interface, the admin panel, and all that stuff, right?
Right.
So there's both.
It depends on the code
Yeah,
that
it
you.
really depends on the project.
Okay, fair enough.
Mhm. What were we gonna ask, Shadiko?
Oh, no, I was gonna ask if you could help me fix my bash console, but I just deleted it.
Oh, yeah. No, if you want, I can hang out for a minute. We can try to fix that. Sure.
No, because I did all the required things and it just wasn't working, so I just deleted it.
Okay. Okay. I mean, if you want, we can try to spin it up, but it's totally up to you. And even after now, if you don't feel like doing it tonight, you can hit me up later and we can do it again, even though the course is technically over. It's true for everybody. If you got more questions down the line or whatever it is, don't hesitate to reach out. We can set up some time, go over things. We can go back through any of this. We got another boot camp coming up in November, right after Veterans Day. You're all welcome to join that as well if you want to go back through the entirety of it or any portion of it. You're still going to be in the Discord server until you leave, so you can hop in, ask questions there, contribute how you like.
I am honored and privileged for the invite, but I'm gonna pass.
I'm shocked. I'm shocked to hear that. Okay.
It's the same boot
Um,
camp that we learned.
Yeah, it's gonna be the same content for the next round. It's not
Oh.
nothing new the next time.
how long is the Discord gonna be around?
Discording.
Our Discord, is it gonna still be around? Like,
Yeah.
or should we email you if we?
No, Discord's fine. Again, unless you leave that server, I'm not gonna kick you out unless you do something wildly inappropriate. So you're welcome to stay there, hop in, you know, reach out, ask questions, whatever you like.
That's wildly.
Okay. Well, thank you. I appreciate you so much. This was a great opportunity.
Okay.
Um,
I'm glad you enjoyed it.
and I may not put it all the way down, but there's a good
No.
likelihood I will.
Again, think about like boot camp. Like when I first got out of boot camp, the last thing I wanted to do was run for like a good couple of weeks. And then I'm like, I feel like going for a run, even though I hate running, So yeah, maybe once you take a step back, you want to get back into it. You might be curious to look into some stuff, but I get you. If it's not for you, it's not for you. I'm glad you stuck all the way through. That's really that is absolutely commendable. And I'm glad you all built the app and at least got to the points that you did.
And
We got,
Aurelius and Alex, good luck in the future. Take care.
Thank you.
thank you.
And I'll be in touch with you, Jeff.
Yeah, for sure, Shadiko. Thanks a lot.
All right, take care. Bye.
Bye.
Jeff, I do
Mr.
have a
Stock.
question before
Sure.
we go.
Yeah.
I got an email from you, this like an intake call. Is that for another round of this or is this for something else?
That's something else. Sorry for all the confusion on that. Let me go ahead and stop the recording on this and I'll answer that question. 1 second.